Okay, the first practice of feature engineering, and probably the most important one, is target assessment and treatment. So the target variable is of crucial importance. You know it definitely by now. Its distribution affects the performance of the predictive modeling drastically. It affects the model's ability to learn. Recall that all models tend to do is learning the association between predictors and the target. So we have to be sure that the target is in a good shape. If it is categorical, this good shape means the categories are balanced. If it is numerical, this good shape means the distribution is rather symmetric. So let's say that our target variable is categorical. This is the category 1, this is category 2, let's say this is like yes and no. And if most of the cases are yes and a few cases are no, we call this one imbalanced. Imbalanced target. And for this case, it's a categorical target. And this is a case that we have to treat it. So imbalanced categorical target means the frequency of categories are not more or less similar. One category is dominated or one category is very scarce or rare. It is said that around 1 to 3% of that is an example actually. So in freemium games, the games that you can play for free and they earn their money selling virtual goods, actually 1 to 3% of the players pay for virtual goods in the game. So if you want to make a predictive model to predict whether a new player is going to pay or not, based on the historical data, your distribution of the target, which is pay or no pay, for other players would be something like this, okay, at the best. And this is problematic, and we need to treat it. We need to do something about it. And why is it problematic? Well, I have explained it here. Because the model tends to learn from dominant class and disregard the rare class. So if the model learns from the no pay, actually this is no pay and this is pay. If the model learned from this 97%, it actually has learned 97% of the data. Okay, it's a very, very good percentage, right? Even though that 3% is very important for us, the model cannot distinguish between this 3% and other 3%. So the model tends to lean towards the majority of the cases. And this is not what we want. Actually, we want to predict this. Okay? And this is the reason that we want to make our target variable balanced. Because, so the reason is the machine learning models and actually supervised tend to learn from the absolute majority and disregard the minority. Okay, so 97% would be the source of learning and this one would be disregarded. We don't want such a thing to happen. So how to do so? Well, two simple ideas, at least one simple, one relatively simple. One of them is, let's take one portion of the dominant class and remove the rest from the data. Now it is something like 50% in the data. It's not 97 to 3%. And now our model learns from both cases. This is the case that we call it downsampling. This is the approach that we call it downsampling. But there is another approach as well. So let me bring that back. What is that another approach? The another approach is, okay, we have these 3%, right? Let's duplicate them, or let's simulate new cases based on them in order to increase the pay cases, the rare category, to a level that it would be 50% once again. It is called upsampling. So there are two techniques. One of them is downsampling, the other one is upsampling. There are packages and libraries and functions and nodes in the softwares that you use that they do this downsampling and upsampling for you. Which one is better? Well, it depends on the situation. There are criticisms for both of them. This one has less, I think that it has more people on the side of downsampling, but both of them are fine, and I'm fond of upsampling because I don't like to lose any of my cases. I like to have more cases rather than discarding part of it. But both of them are totally fine and correct. So I explained why imbalanced categorical target is harmful, and because we want our model to learn from all cases and not just a majority from the point of view of the target. So we have almost the same situation for regression problems. So for regression problems, if the target is heavily skewed, which means something like this, the model would focus on this part and disregard the rest. We don't want such a thing to happen. And how to deal with it? Well, if we can transform this distribution somehow to have something like this, then that situation, the skewness would be alleviated, and therefore the situation would be better. So the model tends to learn from the majority, disregard the cases with extreme values of the target. Also, such distributions are too dense in one range and too sparse in another range. We like to have it more evenly distributed. The models learn better from evenly spread targets. So if it is something like, so what I showed even, it is, let's say that it can be this, there's one distribution that it's like this. The blue one is still better than the dashed yellow one because the variables are more evenly spread over the range. We want something as much as possible, spread as much as possible. So something like this would be even more helpful. Something like this probably would be even more helpful, a distribution like this. And how to do so actually? Well, transformations such as logarithm, and there are other transformation. Logarithm is the simplest one and the most common one. Might be handy in this situation. So if the original target is like 1, 5, 5, 10, 10, 100, 1000, which is actually starting from 1 going to 1000, okay? So it would be 1 here. I don't know how to even draw it because the scale is very strange. But if we do it, if we do a logarithm on base 10, the values would be 0, 0.7, 0.7, 1, 1, 2, 3. So instead of having 1 to 1000, as the range. We have 0 to 3 as the range. And the values are close to each other. They are more evenly spread rather than being very, very skewed. And in a simple example, you can see that how logarithm can change the shape of a distribution. And it was the first practice and probably the most important one. Let's go for the second practice.